Hello viewers, welcome to Rain Computer. In our previous video, we have discussed about state space representation and the features of an algorithm. And today we are going to explain the same thing with an example. And I am going to consider 8 puzzle problem as an example. And we are going to represent this in the state space representation and the analysis of the same. Search problem is defined by the following values, that is state, starting state, goal state, action, solution, cost function and the state space. As I have informed in the previous video, here I want to give the recap of that. That is, what is state? State is the description of the state of the world in which the search agent finds itself. Starting state is the initial state in which the search agent is started. The goal state, if the agent reaches a goal state, then it terminates and outputs a solution, that is the desired one. Action is the all of the agent's allowed actions that can be performed by the agent. Solution, the path in the search tree from the starting state to the goal state. The cost function assigns a cost value to every action necessary for finding a cost optimal solution. And the state space is set of all states involved in this problem. So we are going to represent these things for the 8 puzzle problem. Look at the example. In this tree structure of the 8 puzzle problem, I have started it with a 8 puzzle structure in the representation, matrix representation. From the start state, the root node says that gives me the start state, and to reach the final state, I have given this example with the goal state, with the solution. If you see the bottommost node, there it reached the solution, one of the simple solution for this problem. So to reach the goal state, what are all the moves I have to do? That is what is represented in each level. The first level represents the root node represents the starting state, and the last level, the fourth level, represent my goal state. In between are the moves or the states that are carried out when I move the numbers in this 8 puzzle problem. So in this problem, we can move the numbers in 4 directions, that is either to the left or right or to the up or down. So 4 actions we can do. So if we look into this problem from the first level to the next level, second level, the problem, the space, the empty space cannot be, the empty state can be moved to either down, left or right, but not to the up, because the board is 3 by 3 representation. So we can move down only. The empty space in the top means I can move down, not further to the top. So that's why the second level has 3 nodes. The next level, look into the first node of the second level. It is this space, empty space is at the center. When it is at the center, the empty state can be moved in 4 directions, that is up, down or left and right. So that is why it has 4 nodes following it. It is branched into 4 nodes. But when you look into the first one that I have marked with the green lines, in this, if I move this empty space to the up, then it goes back to the root node level itself. The same state will occur, and the algorithm is going to be recursive. So if I avoid that, I can skip that one and proceed further. So when I do the algorithm, search algorithm, when I write the algorithm, I have to consider if it is going to be the repeating the same state, I should avoid doing that. Why I should avoid? So that it is going to be the recursive, the same original problem will come, the root node will occur. So to avoid repeating the same procedure, so I can skip that node. So what is the benefit of that? We can save time and the space occupied by the storage of this node. So we can minimize the time and space complexity. And two more things for an algorithm we have to consider, that is completeness and the optimality. Completeness means in this example I have given the goal state. So if I reach the solution, I can call this as complete. Just in case I said I want to avoid the recursive, and if I go further and further, I couldn't reach the solution, then it is called not complete. Okay, the solution is not arrived. If I get a solution, then I can call that as a complete. If I don't get a solution, it is not complete. The another thing is, if it is the goal state is arrived with a minimal cost. In this we don't have cost. If I fix a cost, for example in traveling salesman problem means there can be a multiple path to reach the goal state, that is from the starting place to the destination place there can be multiple state, and if I assign cost for each action, then the optimal cost of the path, the minimal cost required for the destination is called the optimum solution. Hope you could understand the properties. There are 4 features for an algorithm: time, space, completeness, and the optimality. Now, as I have mentioned earlier, I skipped it in the third level, the recursive structure, and I moved further to the next level. This is my 8 puzzle problem without the recursive structure. In the previous one, look into the third level. The previous example I have included the recursive. Now I skip the recursive to minimize the space and time complexity. So how to represent this 8 puzzle problem in the state space representation, that is according to the algorithmic structure. State, it is going to be a 3 by 3 matrix, and I can call it as S with the values. What are the values I am having? From 1 to 8 and with one empty square, so that we can move the numbers to reach the goal state. The starting state, it can be of anything. It is going to be the shuffled numbers, can be of any order, so an arbitrary state. The goal state, the state should be arranged in order, particular order. An arbitrary state, example the state given to the rightmost. I have given the goal state in the order then from 1 to 8. That is my goal state. Action, what are we going to do? We are going to move the empty square in 4 directions, either left, right, up or down. That is called the action. That I am going to represent as this empty space, this S. So I am giving it as movement as Sij, because Ij specifies the rows and column. The cost function, if I want to specify the cost, I can include cost in the traveling salesman problem, but here I can just fix it as a constant cost for every action, like I or C or whatever. A constant only it's going to be. State space is degenerate in domains that are mutually unreachable. Thus, there are unsolvable 8 puzzle problems are also there. So as I said, to minimize the time and complexity, if I stop the recursive action, then if I keep on proceed, at one end it stops, all the movements would be over, but I couldn't reach the goal state. If that happens, we can call it as an unsolvable 8 puzzle problem. For analysis of search algorithm, the following terms are needed. The number of success or state of a state S is called the branching factor. How we are going to represent the 8 puzzle in an algorithm. So the branches are there from the starting state. So that is going to be represented as branching factor. B is called the branching factor. B of a particular state I have to mention means then B of S we can use. The effective branching factor of a tree of depth D and with total number of nodes n is defined as that a tree with constant branching factor and equal depth and equal number of nodes. I repeat, the effective branching factor of a tree of depth D and total nodes n is defined as the branching factor that a tree with constant branching factor. Then only we can call it as a effective branching factor. In a search algorithm is called complete if it finds a solution that is solvable. It reached the goal state and it is solvable means we can call that as complete. If it does not contain a solution, then it is unsolvable problem. A search algorithm is called optimal if a solution exists. Always find the solution with lowest cost. There are multiple solutions. The solution with the lowest cost is called the optimal solution. Hope you could understand. The 8 puzzle problem, it is deterministic, which means that every action leads from a state to a unique successor state. So I can call this as an deterministic problem. It is furthermore observable, that is, agent always knows which state it is in. So these factors I am explaining is related to your AI concept. Whatever the agents and the environment we are using, we have to find it whether we have to describe according to the AI concept. We have to describe whether it is deterministic, fully observable or partially observable. All the factors we need to define for AI. You might have learned the search problems already, but in that algorithms we just look into the time complexity and space complexity alone. But when I use that with AI concept, then I need to look into whether it is deterministic or observable. All those factors also I have to consider. So in this 8 puzzle problem, it is deterministic. Why? Because every action leads from a state to a unique successor state. And it is observable, that means the agent always knows which state it is in. It is deterministic and observable. Make action planning relatively simple because due to having an abstract model, it is possible to find action sequence for the solution of the problem without actually carrying out the action in the real world. See, I need not have a number plate and to move every time and find the solution. Here with this algorithm itself, in the offline itself, I can find a solution for the problem. So that is called what I have mentioned here. It is deterministic and observable. Make action planning relatively simple because due to having an abstract model, this is called abstract model, it is possible to find action sequence for the solution of the problem without actually carrying out the action in the real world. Okay, next point is it is not necessary to actually move the square in the real world to find the solution. That's what I want to stress in this. So we can find optimal solution with offline algorithm itself. I am explaining all this factor in relate to the 8 puzzle problem alone. Hope you like this video. In our next video, we will look deep into the algorithms involved in AI, that is the search algorithms and the heuristics in our future videos. Hope you like this video. Please subscribe for our updates. Thanks for watching.